Welcome back. Happy Wednesday. Here's our quick look at our calendar. Today we cover applications of systems day 1. Applications just means word problems. So everything we do today is going to be word problems, and there's going to be 2 pieces to these problems. One is to set up the word problems into equations, and once we do that, we'll have 2 equations with 2 unknowns, and then we'll use the techniques from last class, either substitution or the elimination method. All right, those are our 2 steps. Set up the equations, then solve them using our previous techniques. You'll notice that next class we have day 2 of applications of systems. It's going to be the same idea next class. Next class, the word problems will be a little bit tougher. They'll involve percentages, which will have decimals involved in them, but it's the same idea from today. And then coming up, just looking a tiny bit ahead, on Monday is our review day for test number 1, which is coming up on Wednesday. 1 week from today is our very first test. One big difference between the tests and the quests. If you take a look at the previous quest, it was on lessons 6 through 9. That was 4 sections, 4 lessons. The quest is on everything we have done the entire semester. It's basically a midterm. I'm not calling it that, but we're getting close to the middle of the semester, and that's on everything. All right, so again, good sources of problems are the practice problems packet, the even more practice problems in the big packet that we work on, and of course, lots of stuff on my math lab. That test is cumulative, and it is not too early to start preparing for it. You got 1 week from today to cover 13 lessons. Don't wait until the day before to try to look at 13 lessons of material. Okay, so here we are on the top of page 95, did we say? Our summary. In this lesson, we look at applications of systems of linear equations. These applications involve total value and investment problems. We'll see 2 kinds today. So let's take a look at number 1. 2 types of candy sell for $2.50 per pound and $4 per pound. A store clerk is trying to make a mixture worth $11.70. There's a typo there. I don't know what that BO is. With twice as much cheap candy as expensive candy. All right, $11.70, twice as much of the cheap stuff as the expensive stuff. How much of each type of candy should be included in the mixture? So for example, maybe you want 3 pounds of the cheap stuff and 6 pounds of the expensive stuff. Remember, one is twice as much. I think I got it backwards there. Twice as much cheap. So 6 pounds of the cheap one and 3 pounds of the expensive one. And if you mix that together, it's worth a certain dollar amount, right? We could calculate that. It's probably not the right answer, which is $11.70. So maybe it should have been 8 and 4, right? It's got to be twice as much, but you got to find the magic numbers here that are going to be worth a total of $11.70. So here's our process for setting up the equations. First, we're going to define some variables. Again, if you read carefully, I will tell you exactly what your variables should represent. The final answer to this problem is going to be how much of each type of candy. Those are your variables. One of them is how many pounds of the cheap stuff, and the other is how many pounds of the expensive stuff. Strong suggestion, instead of using X and Y today, I recommend you use letters that are going to remind you of the things that they represent. So I'm using C for the cheap stuff and E for the expensive stuff. Trust me, it will make your life easier when you set up the equations. Calling everything X and Y is quite generic. It's totally fine, but it's going to give you more to think about as you set things up. Okay, here's a table. We're going to organize the information in a table. And I'll say at the outset that I'll never require you to do a table. Ultimately, the goal of the table is just to help us write down the equations. And if you can get to the equations accurately without the table, great, no problem at all. So let's start filling in. The cost per item, or cost per pound in this case, is the easiest place to go. How much does the cheap stuff cost per pound? $2.50, we're gonna put that right there. And fill in the number just below that. So right below that, we'll just put 4 or 4.00. Okay, let's take a look at the first column. It says number of items. In this case, it's number of pounds. Number of pounds of cheap stuff. I don't know, but I gave it a name. What did I call it? C. That's our variable. It's the number of pounds of the cheaper candy, and then down here, number of pounds of the expensive candy. I've got a bottom row there called total. Oftentimes, you're given information about the total mixture. In this case, the total number of pounds of candy is not given. In some other problem, it might say you have 10 pounds altogether, and you would just put a 10 here. But it's not given in this problem. The total cost per item, also not given in the problem. In some problems, it might say you want, on average, the stuff to cost $3 a pound, and you put a 3 down there, but it's not given. So let's take a look at this last column here. And I will say this, suppose, just to pick a number, suppose that C is equal to 4 pounds. What would the total value of 4 pounds of the cheaper candy be? $10. How did we get that? 4 times the 250, right? That's how you'd figure out how much the cheaper candy is worth. So what I'm trying to put here is that same idea, but instead of 4 times 250, it's C times 250. So right over here, we're going to put 250C. We buy that? Just multiplying. It's the number of pounds times the price per pound. It's the same idea when we did those books and CDs problems a while back. Number of CDs times the cost per CD. Number of pounds times the cost per pound. In this next column, next row, what are we putting? 4E. You don't need the zeros, but I'll include them. And I'll point out for what will be many times that I'll say this, if we set our tables up in just the right way, the last column is going to be the product of the first 2 columns. That's written down here, it's underlined. The last column is created by multiplying together the first 2 columns. We'll see this is quite common, okay? All right, and then the total value of the entire mixture in this bottom row, that's given as a number in the problem. What is it? That's 1170. There we go. So our table is filled in. You're going to take your time as you create these tables today. And now we're going to write down 2 equations. So one of them, we need to capture this idea right here. Twice as much cheap candy as expensive candy. Translating that, one of these variables is double the other one, right? Like I had said, 8 pounds and 4 pounds, for example. So I'm going to write down 2 equations, one of which is right and one of which is wrong. E equals 2C, C equals 2E. Those are the 2 ways to write down that one of the variables is double the other, right? 2 times. But we got to make sure we pick the right one. Twice as much cheap as expensive. What do we think? Can you guys vote? We voted yesterday, right? Raise your hand if you think the left-hand equation is the correct one. Got a few votes there. Raise your hand if you think the right-hand equation is the correct one. Good. And then we also have some people that abstained. I thought everybody would rock the vote right here, but no. Right. So it's tricky here because it says twice as much cheap. And so the 2 and the C appear to be associated with each other. And this is the equation where the 2 and the C are associated. Sadly, that is not the right equation. Because really, in English, what is this saying? Which one is more, the cheap or the expensive? Is that what it says? It says twice as much cheap as expensive. The cheap stuff is twice the expensive stuff. Yeah? That's what that really means. And the cheap stuff is twice the expensive stuff is that equation. The cheap is twice the expensive. And this is another one of these places where the English language is not doing us any favors as we translate into equations. Right? So you just got to really take your time. Make sure you put the 2 on the correct side. So C equals 2E is one of our equations. So we've got that guy. And then the other equation is more straightforward. You've got this column right here. The value of the cheap stuff is 250C. The value of the expensive stuff is 4E. The total value we're after is $11.70. We're just going to add the first 2 things and make it equal 1170. And that is written right here. 250C plus 4E equals 1170. And we've also got our other equation, C equals 2E. Okay? So there's the setup. We're not going to spend our time together right now solving it, but solving it is a whole separate problem that you might have done in the last class, right? Either substitution or elimination. My personal choice here would be substitution because one equation is already solved for one letter. That first one is already solved for C. So you could just immediately plug in for the C in the other equation. Okay, so you can try solving that later. I've given you the answer here in part D. It's 2.6 pounds of the cheap stuff and 1.3 of the expensive. You can verify later. Okay, let's move on to number 2. It says the amount of money that is deposited in a savings account is called the principal, and the money a person earns from the bank is called interest or interest income. And if money is invested for 1 year, then the interest equals the principal times the rate. So here's our little equation, I equals P times R. Let's see if we buy that. Suppose that you have, I don't know, $200, and you invested at 10% per year. And I just want to know how much we have at the end of 1 year. We're just specifically looking at a 1 year into the future problem here. So what would we do to find out how much interest we gain? We multiply, right? You're just looking for 10% of 200, which means multiply those together. When you multiply them together, you do have to make one change. What do you change? 10% becomes 0.10, right? We always change percentages into decimals when we want to use them. Yeah, and so we do the calculation here. So that's $20, but more important to me is the fact that the interest is the principal times the rate. Right? So that should not appear to be some magical equation, I equals P times R. It's something that you know to be true, even if you haven't thought of it symbolically in that way. Okay, so here's our problem, number 3. Jerry invested a total of $2,000 in 2 different banks. The first bank pays 4% interest and the second bank pays 9% interest. His yearly income from the 9% investment is $37 more than his yearly income from the 4% investment. How much did he invest at each rate? Okay. So one possibility for the 2 banks is that he invested $1,000 in each. We have $2,000 altogether. Or maybe he invested $1,500 in the one bank and $500 in the other bank. Or maybe it was $1,200 in one and $800 in the other. And there's a whole ton of different possibilities here, right? Lots of ways to split up that $2,000. And it turns out that there's exactly one way to split up that $2,000 to make this complicated thing work. That the interest you get from the 9% is 37 more than the interest you got from the 4%. So that's what we're after, is to find the one way to split up the $2,000 to make that true. Again, if you look carefully, you will see that I'm telling you what the variables should be. How much did he invest at each rate? Super, that's what our variables should be. One variable for how much he invested at 4% interest, another variable for how much he invested at 9% interest. X and Y are okay. I would rather use variables that represent the things that remind me of what these things represent. So I'm going to use L for the amount invested at the lower rate, 4%, and H for the amount invested at the higher rate, 9%. Okay, so we've got a table. Table looks quite similar to the table up above. We've got a row for the low, a row for the high, and a total row. The interest rate is the easiest column. We'll start there. What's the interest rate for the low investment? 4%. I'm not going to write 4%. I'm going to write 0.04. Right, so we immediately translate percentages to decimals by moving that decimal point 2 places to the left. And the high, 0.09. Right, don't put 9 there, 0.09. Okay, next we're going to the first column, the amount invested at the low rate. That's one of our variables. What is it? That's L. Amount invested at the high rate. That's H. And then the total amount invested, 2,000. So that's filled in, and you might already see that you're going to get an equation from that column. Okay, let's come to the last column, amount of interest income. Okay, just reminding ourselves that the interest is the principal times the rate. Well, this column right here, amount invested, that's the principal. This next column is the interest rate. Now, what do we do with those things to get the interest? As we multiply them. So we'll just write here, it's that exact equation, right? And like we said before, oftentimes when we set up these tables, you're going to multiply the first 2 columns and put it in the last column, which is kind of surprising because this problem really has nothing to do with the candy, right? It's a really completely different context, but still we've set up the table in just such a way that we can continue to multiply the two columns and put it in the last column. So here, 0.04L, here is a 0.09H. And some of you might be tempted to try to get the 37 into this table someplace. It doesn't go in the table. We've got everything in the first two rows filled in, so it's not going there. And the last row represents total, and that 37 doesn't say anything about a total. So the other two blanks are going to stay blank. Don't try to force things into the table. Okay, so let's see if we can get some equations. Here's our first one. Can somebody translate that into an equation? L plus H equals 2000, which should remind you an awful lot of how we set up this last row up, last column into an equation, right? 250C plus 4E equals 1170. Add that. Okay, so we've got one equation is the easy one, is the L plus H equals 2000. The other equation is tougher. Now the fact is it's, oh good, it's not on this page, it's on the next page, so don't look. So we can write this here, L plus H equals 2000. Don't look on the next page. And now we're going to translate the more complicated sentence into our other equation. So here we go. The yearly income from the 9% investment, I'm pausing there. That is one quantity and it is in the table. What's the income from the 9% investment? It's the 0.09H, that's exactly it. That's the interest or the income from that investment. So that translates to 0.09H. Is that symbol equals 37 more than, how do I say 37 more than? There is a plus, 37 plus, right? 37 more than something. The income from the 4% investment that is in the table, what is it? 0.04L, that's that guy. So there's the equation. And we took it piece by piece. Kind of looks like a ransom note with all the different colors at the bottom. Yeah, and there's a lot of ways to write that equation wrong. And there's only one correct equation, it's that one there. But you just got to take it slowly and translate piece by piece. So those are our two equations. Again, we're not going to spend our time together solving the system. I'm just focused on setting it up, and we're done with the setup part. This one, just one recommendation. If you don't like those decimals in the last equation, what can you multiply that whole equation by to get rid of all the decimals? 10 will move the decimal places one spot, decimal points one spot over. Multiplied by 100 will move the decimal points 2 spots over. So as a very first step, if you don't like these decimals, multiply both sides by 100. 9H equals 3700 plus 4L. You might find that easier to work with. Okay. All right, so I think that is that. On the next page, it does include the answer there, part D. You can check that later on if you want to. There is kind of a generic problem solving process set up here, so that's a nice reference for you for later. But for right now, what I want us to do is start the activities. And I just want to point to these bolded and underlined directions because this is unusual for us. What you're going to do is you are going to set up your two equations, which probably means first filling in all the stuff in the table and defining your variables. But once you set up your equations, you're moving on to the next problem. What I'm more interested in is the setup today than the solving. You should have time to set up all 5 of these and then go back to number 1 and start solving. But I don't want us to start solving anything until we've set up all the equations for all the activities. Okay? All right, raise a flag if I can help.